In the last session, we were looking at mono-alphabet substitution ciphers. So what do you mean by mono-alphabet? Say if this is the plain text, Satish, and you're going to take every alphabet and substitute that with another alphabet, say J, U, P, A, G, something like that. Yeah. So you're going to substitute, we take one alphabet and substitute it with another alphabet. So we call that to be mono-alphabet. In this session, we'll be taking a look at multi-alphabet substitution cipher. So what is that? Say if your plain text is Satish again, here what we are going to do is we're going to take two alphabets together, multiple alphabets together, and maybe we substitute this as KL or something. So what is multi-alphabet substitution cipher? Take multiple alphabets, substitute that with multiple alphabets or symbols. So here we can easily divide this as two alphabets and two alphabets. And these two alphabets together are called digrams. And in today's class, we'll be looking at Playfair Cipher, which will be working on the concept of digrams, that is taking two alphabets and substituting that with another two alphabets or symbols. So we'll take a look at what is this Playfair cipher. This is best known as poly alphabet cipher or multiple letter cipher or multi alphabet cipher. So it is a multiple letter encryption cipher and it is known as Playfair, which treats diagrams in the plain text as single units and translates these units into ciphertext diagrams. I told you what is a diagram. In your plain text, you take two alphabets together, that makes a diagram. And the main concept behind Playfair algorithm is it uses a 5 cross 5 matrix, and using this matrix encryption and decryption happens. So the very first step in Playfair cipher is we need to choose a key. A key can be anything. Say here we are choosing the key as scope or department name. So we'll choose this string as the key, and after that step 2 we have to go and construct this 5 cross 5 matrix. So we'll go and see how to construct that matrix. So this is a 5 by 5 matrix, and in the very start of this matrix we give this key, that is SCOPE. We enter our key, and in the remaining columns what you're going to enter is all the alphabets starting from A to Z. And when you're entering A to Z, you have to skip SCOPE. So all these alphabets should be present only once in this table. So if you've already entered P, we're not going to enter P again. Let me tell you how this happens. So we have entered the key first. Next we'll start with A. Then we go to B. C we have already used, so we'll skip C. We'll go to D here. And E we have already used, so we'll go to F. Likewise G, H, and the next catch is the letters I and J are represented in one box. So why we do that in one box is because totally we have how many boxes here? 25, 5 cross 5. But in English language you have 26 alphabets. To accommodate that one extra alphabet, we put I and J in the same box. Okay. So K, L, M, N. You see here O and P we have already used, so we'll skip O and P. So next comes Q, R, S we have already used, so it is T, U, V, W, X, Y, Z. So that's how you create this 5 cross 5 matrix. Very simple. First take a key, fill that key, and whatever alphabets that are remaining apart from the key from A to Z will be filling in the remaining boxes. But what we do is we put I and J in the same box because you have to accommodate 26 characters in 25 boxes. And the only important thing is none of the characters should repeat in the box. So our matrix is ready. Now we can go and take a look at encryption. For encryption, the very first thing is you have to take some plain text, right? So this plain text I have taken as a very funny plain text. Satish is sleeping. So this plain text should be encrypted. And even before encryption, there is a rule one that comes with Playfair Cipher. That is, You have to closely watch the diagrams in this plain text. I have given the diagrams here: Satish, Satish, SL, EEPING. So whenever there is a diagram in which the characters repeat, say E and E, this diagram has the characters repeating, then what we are going to do here is, instead of this E, we are going to substitute an X, and then we are going to push that E to the next diagram. So we don't want the characters to repeat. For instance, if you take balloon, here L and L repeats, right? So we give LX and we push this L to the next O. So it's LOON. So that is the very important thing. We have to split them and we have to see whether there are any two alphabets repeating in a diagram. So here you see now it is not repeating: SATI, SHIS, SL, EX. Now this E is pushed here: EPIN. And finally you have only one G remaining, and this is not a diagram, right? So we need two alphabets. For that we'll pad that with an X. So we ensure that when we split, we have minimum two alphabets. If suppose your string ends without another alphabet at the end, you can pad it with an X. So that's what I have done here. I hope these two steps are clear for you. Now our message is ready, but ensure that there are no repeating characters in a diagram in your message, and if there is a single character at the end, pad it with another character. Now let's take a look at how to encrypt. For this, we need this 5 cross 5 matrix that we have built, and we need our message to Satish is sleeping was changed according to the previous slide. Now we'll take every diagram SA. So where is SA here? S and A fall in the same column. So they are in the same column. So once when two characters are in the same column, we have to apply a rule. That is, you go to the first character and then take the character behind it or beneath it. So what is beneath S? A. So S will be substituted as A and A will be substituted as H. So what is beneath A? That is H. So the rule is very simple. If you have two characters or from the diagram SA applying or coming in the same column, so you see this is coming in the same column, right? So once when that is the case, you take the first character and see what is the character beneath that. It is A. So you substitute S as A. And what is A? You go beneath A. What is beneath A? It is H. So SA gets converted to AH. That is the rule when two characters from your diagram fall in the same column. So we have already encrypted this, right? So what we have done is we have found what is SA. SA is AH. Next, TI. Where is T and I? So here is IJ and here is T. So now there is a different rule, right? They are not in the same column or in the same row. So in that case, what we have to do is we need to just find the values like this. Say you take T, you traverse in the same row until you see an intersection with IJ. So what is the value here? Q. So this Q you're going to take and substitute that instead of T. Likewise, IJ, we just traverse in the same row in this direction until we see an intersection with T. So what is the value here? L. So we know what we have to do when the characters are in the same column. We know what we have to do when the characters are in the different rows and different columns. Now let us take SH. Let me write it for clarity here. SA, we have encrypted that as AH, and TI, we have encrypted that as QL. Now we'll take SH. Where is S? S is here, and H. So again, both these characters S and H are in the same column. So what is the rule? You go beneath, find what is the character under S. It is A. So for S, we'll substitute A. And H, what is the character beneath H? It is N. So SH is encoded as AN. The next diagram is IS. So where is I and S? So here is I and where is S? S, they are in different rows and different columns. So we start with I, we traverse to see where we intersect with S, so H, so we take it as H. And likewise S, where it intersects with I, you traverse, so S intersects with I and this place is C, so we take it as C. So IS is encoded as HC. Now let us go and encode the next thing, that is SL, encrypt it. Can you try SL? S is here and where is L? L is here. Again they are in two different rows and columns. So we have to just encode S first. So you travel to this side to see where we intersect with L. So this is the P, right? We meet L in P. So we are going to take P. And likewise L, how it meets S, you traverse in this direction. So here H is the one, uh, H is the value in the row wherein we intersect with S, so we substitute that as S. So we have finished so many things. Now let us go and take the next SL we have done. What is EX? E and X. Where is E? E is here. Where is X? X is here. Again, two different rows and columns. So where is E? E is here. Where is X? X is here. So how E meets X? We'll travel in the same row, and this is where E meets X. So the value is O. For E, we'll substitute as O. Likewise, X, how it meets E? We'll traverse in this row. So it meets E through Z. So it is OZ. So we finished EX. Now let's take EP. Can you try EP? So E is here, P is here. So this is now a different case. So E is here, P is here. Now two values are occurring in the same row. They are not in the same column, they are in the same row, E and P. So this is the rule. If two plain text letters fall in the same row of the matrix, or each replaced by the letter to the right with the first element of the row circularly following the last. So it's very simple. If they follow in the same row, say for P, how we are going to encrypt this? We're going to go to the right, take E. If there is E, there is no element in the right, so we're going to go to the front, we're going to take S. So it's circularly wrapped around. So now let's go and select E. So E and P are in the same row. So we are here in E. There is no character after E. So we go to the first and then we select S. For P, P is here. So we'll select E. Let me again explain this with a simple example. Say if you want to encrypt B and F. Say if you want to encrypt B and F, what will be the output? Say B and F fall in the same row. So what we do is we go to B, take that character occurring to the right of B, so we QT. And we go to F, take the character occurring to the right of F, that is G. So that's how elements in the same row are getting encrypted. The same concept you applied here. For E, there is no element in the right, so you are taking S. And for P, there is element in the right, that is E. Okay. So we have finished EP2, we have finished EX. What is IN? How will you encode IN? This is I and this is N. They are in different rows and columns. So how N meets IJ? It travels here and it's Q. Or how I meets N travels in the row, so it is H. So for I will be encoding it as H and for N will be encrypting it as Q. GX. That is our next and final diagram that we need to encrypt. Where is G? G is here. Where is X? X is here. So again, they are in different rows and columns. So you traverse and see how G meets X. So G meets X in T, and how X meets G. You traverse in the same row. It's C. So Z. So we have applied all these rules. What happens when two letters are in the same column? What happens when two letters are in the same row? And what happens when two letters are in different rows and columns? These three rules we have applied and we have encoded or encrypted our plain text to this ciphertext. Is that clear? Now let us take a look at Playfair's decryption. How we decrypt that. For that, again, we need this matrix. This matrix is the key, and we're going to take our ciphertext. This is what is the ciphertext we have achieved, and I've split that as diagrams here for your reference. And we have to go and get our plain text message from this ciphertext. We'll see how to do that. So we'll take the first two alphabets here, A and H. You see A and H, they occur in the same column. So now we are going to reverse it. Earlier we are taking the character underneath. Now we'll take the character above. So for A, what is the character above A? It is S. For H, what is the character above H? It's A. So it's the reverse. When it compared to encryption, it's the reverse. In encryption, we're taking the character underneath. In decryption, we'll be taking the character above the character. If both these characters, say if A and H fall in the same column, that is the rule. Likewise, let's take Q and L. This is Q, and where is L? L is here. Now they are in two different rows and columns, so we have to see how they meet. So Q meets L in T, so we are going to substitute Q with T, and L meets Q in I and J. So we'll just put I bar J here. Right. So we have finished decrypting AHQL. Can you try decrypting the other diagrams? So now let us take a look at AN. What is A? This is A. Where is N? Okay, they are in the same column. So what is the rule? Go to one character above that. So A is replaced as S, and N we go to one character above that. It's H. So we finished AN. What is HC? You see H is here, C is here. They are in two different columns and rows. So how H meets C? You'll have I comma J. So instead of H, we're going to put I or J. And what is C? C meets H like this. So yes. So we finished this too. What is PH? Let me go and erase this. So P is here, H is here. How P meets H? So you see here, S is the intersection of P and H. So you just give S for P, and for H, the intersection of H and P is L. So we can give L. So finish this. O and Z. Where is O and where is Z? This is O and this is Z. So they are in two different rows and columns. So how O meets Z? So it just travels here. This is the intersection of O and Z. So you give E. And how Z meets O? So Z meets O in X. So we'll just give X. Now let's go with S and E. For that, let me again erase this. So S is here. Where is E? E is here. Now these two characters are following in the same row. So what we have to do is earlier in encryption, when we add them in the same row, we used to go to the next character. Whereas in decryption, when S is here, we have to go to the character to this side. So for that, there is no character this side. So we'll go and see what is that at the end. So this is E. So for S, what we are going to do is S is going to be encoded as E. And what is E? So you have E here. So we go one character to the left. So that is P. So if they are in the same row and you want to decrypt it, just go to the left. If you want to decrypt BD, what is for B? It is A. What is for D? It is P. Just the reverse of encryption. Now let us take HQ. Let's see what is this HQ. H and Q. So we have H here. H meets Q in IJ. So we can put I or J here. And Q meets H in N. So we can put N. And finally DZ. What is DZ? We have D here and we have Z here. So D meets Z in G. So always go to the opposite side. So it is G and Z meets D in X. So we have finished decoding. So what is this? This is the plain text message. But the very first thing that the user should do is he should remove all the X because he knows that X is something that was padded to the original text. So if he removes all the X, so there is an X here, there is an X here. So you can very well guess where he has to remove, right? So it is nothing but SAT, and you can also frame the word. SATJSH doesn't have meaning, so you can say Satish. He knows his friend's name, so Satish. Likewise, JS or IS will take from here, and SL and E. We'll discard this X because it's padded. We'll put EP and JN has no meaning, so we'll take I here, IN. GX will discard the G. I mean, we'll discard the X and take the G. So now he's able to get the plain text Satish is sleeping. So that's how you encrypt and decrypt using Playfair Cipher. And for that, the main concept is the matrix, the key, and then the rules that we follow when characters appear in the same row, same column, or when they are in the different rows and columns. So poly-alphabet ciphers or multi-alphabet ciphers give us more security. So there are almost 676 diagrams when we have only 26 letters, and it is really secure than our monoalphabetic ciphers. And for long, Playfair ciphers were considered to be unbreakable. Say it was used in World War One by British Army, and it was also used by the US Army and other Allied forces in World War Two. So it has played a very crucial role in killing people, I guess. And despite all this level of confidence in its security, Playfair cipher is relatively easy to break. So when you have 100 letters of ciphertext, then they say it's generally sufficient to break Playfair cipher. So with that, we'll come to an end of our discussion on Playfair cipher. I hope you have understood this. Thank you.